Hey everyone, we are in another lab tour in QTT, which is a research center for mechanical and materials and manufacturing. And here we have Wes and Said, which are two PhD students. So let's talk a bit about your research, about what you do, and about some cool stuff. So Wes, could you please introduce yourself a bit and tell us about what you do?
Yes. Hi, I'm Wes. I joined the DMS group 2 years ago, and my thesis topic is laser welding monitoring. So we use camera, microphone, and OCT to record the welding process and then to analyze the keyhole dynamics. So we can use this data to find out more uh, in the keyhole and the welding process.
Cool. Yeah, that's really a lot of different sensors. Is very very cool, very interesting. What about you, Said?
Yeah, so hi, my name is Saeed, and thank you, first of all, for having me. I'm super happy to be here. And I started my research topic 3 years ago, and I joined this group almost more than 3 years ago, let's say. And then when I started, I was not actually working on this project, I was working on another project. I joined the project halfway through, and my main role in this project is to take care of the laser welding side of the monitoring. So we have two different sides. We have laser welding side and we have the monitoring side. So I'm taking care of the parameter related to laser and how the parameter change the properties of the interaction between laser and material.
Well, very cool. And laser welding is a manufacturing process that can be applied for many things. So, what exactly is the application for this research?
Yeah, for this particular research, we are focusing on shipbuilding application. So the main goal is to push laser welding to industrial applications such as shipyard. Because at the moment, we don't have pure laser welding in this high section, heavy industrial section, because they use kind of like hybrid of laser and arc welding. So the aim of this project is that to first of all to prove that laser welding could be a feasible way with sufficient monitoring, backup, and background provided to them. So the aim is to really push laser welding as a single technology that can be used by itself without any assistance of ARC or other technologies.
Yeah, because there are so many different technologies, as I understand, for welding, and laser is like one of the most advanced ones and has much more reliability. So that's why this research is super relevant. And what about how did you find about this opportunity? How did you join the group?
Mm.
Because yeah.
Yeah, that's a really good question. I remember when I was searching for some position, I wasn't like really focusing on Finland, but I found some really nice opportunity on LinkedIn actually. And then I read a little bit about the group, and then I found that this group is really actually focusing on laser material processing, which is really my background. And I read a little bit more. I found more detail about the group and what kind of research topic they are doing. And then I found it really interesting. And then I applied for the position. And I think it took a while, and then they got back to us as like a short list people, and then we had a couple of interviews, and then after that I got the result, and I was selected for this position.
Well, very cool. It's very interesting that you could but you could also see online, and that sounds very cool.
Absolutely, yeah,
That sounds very
that's so
cool.
true. Yeah.
What about you, Wes?
So for me, I found this job on the website of University of Turku as a project researcher. So it was a time that I finished my master thesis on the terahertz uh, radiation characterization materials. So it's similar as the current project that we use optical method to characterize the materials and then analyze this data with MATLAB or Python's scripts, and then we can um, get more information from this data. So this is how I found this job.
Okay, well, that's very interesting. Yeah, like you come from very, let's say, advanced backgrounds. Like you were working with laser and you were working with uh
Terahertz.
yeah, like terahertz measurements. That's very interesting. And about the group itself, how is the work structured? Like how often, for example, do you do experiments? Do you do collaborations? How does it work?
Yeah, I mean I think that's a really important aspect of a group if you want to really like advance in research and science. So in that regard, I think we do quite a lot of experiment within this project that we mentioned already that we are working on, and I would say at least once a month we have some experiment going on to make the data more reliable and do more, like collect more data to be able to analyze them. So regarding the experiment, we have it quite at least once a month. We have experiment, and then the gathering and the other, let's say, meetings that we have within every 2 weeks. Actually, we have within our group, we have meetings to just share our ideas or just research topics or anything related to research, or if we have some question or some, even if we have some difficulties progressing in some topics. So we just share all of this in our internal group every 2 weeks, I think. And then regarding collaboration, yeah, that's also really vital aspect of a research group, I would say. So actually, I have actually one really good example of that, because we started collaborating regarding this project with a university in Denmark. So I'm going to do a research visit as well regarding that. Because sometimes it's really important to work with other equipment than what you have here. So it's a way to kind of collaborate and share knowledge as well. So that's one aspect of this. So we do also collaboration and research visit with other university or even other countries.
Yeah, that's really interesting, right? Because sometimes you are working only with one equipment, you get so used to it, but of course every time you change your setup a bit, you're learning a lot, and that's like very cool. And you're both in the same group, so do you have anything to add on top of what Said said?
Yeah, so for example, we have a lot of laser facility, so we can do the welding process, but we don't have the fatigue testing at the same time. So it's possible to collaborate with other university, so they can do the fatigue testing parts, and then we do the welding part, so we can write a nice publication with that.
Yeah, wow, that's cool. That's very cool. Yeah, so you just talked about like this laser processes and this laser equipment. Would you have like something cool to show us, like for yeah?
Absolutely.
Yeah.
Absolutely.
Let's go there.
We have really cool stuff going on at the moment.
Yeah.
We would be really happy to share and show you.
Want to have a look?
Yeah, let's go.
Yeah.
Cool. This looks truly impressive. This like looks a very cool setup. Could you please explain a bit like what it is? Do you want to start?
I can start.
Sure.
Yeah. So welcome to our lab, and this is the equipment, or let's say the setup that at the moment we are developing. So as I mentioned, we are dealing with laser welding during this project. So we have our laser welding all the way delivered here. We have the fiber and here, and the laser is here. And we have quite a lot of equipment which are used for monitoring of the process itself. So we have cameras here, we have cameras here, we have microphone, and we have distance measurement equipment by laser, which we use to measure the depth of the keyhole or the weld area. So with this equipment, we are able actually to have information about the whole area of interaction between laser and the specific material that we are using. And that's a really vital information for us, because we need to see what kind of processes we are dealing with to be able to control it. So that's the whole idea of having this many sensor and equipment to just see that tiny area of interaction area.
Wow, cool. And regarding the data processing, like how complex it is, because we see there's a lot of different sources of data here, right? So could you explain a bit how it works and what are you doing with the data?
Yeah. So I will take one example of here. This is the coaxial camera that we're using, and then there's a active illuminations laser to have the lights around the area, so the image is not overexposure by the laser process itself. And then when we have this image, we can run it in the Python to have some morphological transformations, and then we can extract the keyhole area and calculate the size and the color of the keyhole area to help us understand what the laser welding process is. At the same time, we have the high acquisition rates of the laser acoustics microphone, so it can tell us maybe there's some anomaly of the acoustic emissions that may form the defects during the process.
And about the experiment itself, like how do you design this type of experiment? Like what different parameters do you play with? Because there's so many different things here.
Yeah, so the most important part for us to have data from different ranges. So we could go with the optimal parameter, which let's say, but that's not the goal, because we need to see what kind of problem we have during welding. So we kind of induce those problems as well during welding to be able to see how data could perform when we have anomalies in the weld. So we use wide range of parameters for this particular one to have data from all the available possible anomalies during welding. And then all the way we will optimize the parameter to get to the best possible weld we can reach. So that's the way how we kind of, let's say, design of experiment that we do. We use a wide range of parameter to be able to see all the anomalies in the weld as well.
Yeah, that's very interesting. Like, for example, there's a variation of laser power, so you use a range of different laser powers, and you analyze and you actually perform the weld, and you analyze, for example, if the material has been like fused together and how well it has been, for example, solidified. And from the camera, you can also analyze, for example, if the geometry of the area has been like was good.
Yeah, in that regard, the most like important parameter that we would work on that would be the laser power and the scanning speed. Those are the two major parameters that would affect the welding quality. And then apart from that, also the focal length or focal point is another parameter that we would play with during this project as well. So those are the three main parameters.
Yeah, and of course, you can deal with different materials, right?
Yeah, absolutely. So I think so far we have tested 3 or 4 different materials. So it's not just because once we have data for one material, then we need to verify that data. Is that data reliable for other material or not? So that's why we change material, we collect again data, and then we kind of reach the data as much as we can to be able to have some reliability in the data itself as well.
Yeah. It really looks like you have a very cool setup, and you can really like change a lot of things. Like you can change the material, you can change the laser power, and do like, let's say, this bulk data collection, which sounds very interesting.
This setup at the moment that you see, now we are comfortable with it. So we just change the parameter, we change the material, because we know the sensor now. We know how they work, what kind of data we are collecting, and how we kind of analyze those data. So that's why we are now really fast in this regard.
Yeah, that's very cool. And as we mentioned before about like each, let's say, new sensor that you're working with is like some learning curve, and you learn a lot. Like you have to, for example, understand a bit of the physics of how each things work here. Could you like tell us a bit about like what sensor you have worked with? Because mostly the OCT, right? So you have to learn a lot about that.
So OCT is the optical method to measure the distance. And the distance is measured by the interference patterns. So you have 2 beams. One is the reference beam, one is the probing beam. So you can see the time difference of these 2 paths from the interference pattern. So you can measure really tiny distance difference. For example, of the keyhole depth, you can have accurate keyhole depth measurements. And because the wavelength of the beam is different than the laser process itself or the laser illumination for the camera, so there's no interference influence from other color of lights. So it's a really accurate way to measure the keyhole depth.
Cool. Very, very interesting. Sounds very exciting and very complex at the same time. And I mean, now let's talk about a bit more general terms. So would you give, for example, some advice to some master's student that is thinking about joining UTU, or some PhD student that is like thinking of applying, or maybe got an acceptance letter and is deciding? What would you say, for example, about Turku and UTU, about it as a place to live and do research? Yeah, let's start with Saeed.
I could actually share a story of myself, like how that happened. Actually, when I was at my last year of my bachelor, I took an optional course in laser material processing. I did not expect what I was getting there, but that course really took me to a whole another level, and I found like interaction between light, let's say laser, and material was really intriguing to me. I was like, I'm going to continue this, and that's exactly what I did for my master. So I continued on laser material processing. I took a lot of courses, a lot of experiment, and I worked mainly with additive manufacturing and laser welding. So for those students out there, especially master student, if you are really interested in laser material processing, I'm just generally talking about laser material processing. But specifically, if you are interested in additive manufacturing and laser welding, do join our group, because we have a lot of facility and a lot of research topics going on these particular techniques. So do join us, and you will find it really interesting doing research or studying it here.
Very cool, very nice. Would you like to add something?
Yes, so it's really nice facility work here. For example, here we have really nice ABB robots that we program all the instructions into the script, so we can turn on the sensors simultaneously and then start the process precisely. And then we have these nice alignments of the videos and the acoustic sound audios, and also the OCD data. So with this facility, we can understand more about this laser materials interaction process, like laser welding or additive manufacturing.
Mm-hmm. Very cool. And would you give any advice for people that want to join here?
For me, I think you need to enjoy the process, and this is really nice to learn more about all different devices. You have different kind of sensors, and then you have the control system from ABB robots, and you have different computer to work with this sensor as well. So it's a lot of interesting things that you need to keep trying to learn new things, and then you learn, and then you find this process really a lot of achievements during the process.
Wow, very, very cool. Now moving out now into our final question. Here at UTU, we're inspired by many things. We're mostly inspired by science. But could you complete this phrase? Get inspired by. What are you inspired by?
I mean, the first thing comes to my mind, I would say, get inspired by laser.
Wow, that's very cool. And what about you, Wes?
Get inspired by material science.
Well, thank you so much, guys. Thank you so much. I think it was a very nice interview, and see you in the next video.